Here we have with us Dr. Russ Altman. He's from Stanford University. Welcome, Dr. Altman. It's a pleasure to have you and honor to have you here at the ASC conference. Tell us something about yourself and what are you working on? What research?
Yes, so I'm in faculty at Stanford in bioengineering, genetics, medicine, and computer science. So I have 4 departments, and I work in the area of biomedical informatics. And we're interested in using advanced computational technologies, including big data, but also small data sometimes, to uncover biological discoveries that can improve human health. Much of our focus is on how genetics influences drug response. It turns out that when you inherit from your parents your response to drugs, just like you inherit the color of your hair and your height. But most people don't know about how their parents responded to drugs, so we can use genetics to pull that information out and try to improve drug use. As part of that, though, we're very interested in mining any data source that has information about drug response. And that's what gets us at the molecular level, how the drugs are interacting with the biological molecules, all the way up to the population level where we study drug side effects and drug response in patients. That's what I talked about today.
Yeah, it was a pretty interesting speech. I got peaks of it. But yeah, I mean, people in biomedical computing, the researchers, what do you think are the industry expectations from the biomedical researchers in the next coming 5-10 years?
In terms of the capabilities that industry should deliver, I think that one of the big problems right now is data storage. I think this is a problem for everybody. The human genome is 6 billion bases, but the experiments that are required to get that are becoming very cheap, and the raw data is more like a terabyte. And so if you start sequencing 1,000, 10,000, or 1 million people, we have big storage problems. In fact, some people think we should just store it in the DNA because the digital storage is too expensive. Cluster computing, easier ways to take advantage of multi-core architectures. I think there's a lot of interest in how can we efficiently program algorithms so that they will run on all the new platforms that come out. It's very expensive and hard for an academic to recode old algorithms into new languages, because once you write the paper, it's no longer that interesting, it's not innovative, even if it's valuable. So we're depending on our industry colleagues to create ways for us to have our codes transferred from one architecture to another without us having to do a lot of work, because the students won't do it very well, they're not professional coders. We can't do it ourselves. So this is an important area. And then I think sensor technology. I think the ability in medicine to instrument people as they live their life, accelerometers, physiological monitoring, this would all be incredibly valuable for healthcare. And so I'm hoping that as things get small and cheap, we're able to really get good sensing of individuals' physiology and their environment, which will help health very much.
Well, thank you so much. We really appreciate your time and effort, and it has been great to have you here at the Academy of Science and Engineering Conference. Thanks for your time.
Thank you very much.
Have a